In this video, we will look at how to differentiate functions that aren't in the form y is equal to f of x. So the main type of examples that we'd see would be where the x and the y are together and you can't solve for the y in order to find dy dx. We call this implicit differentiation. So an example would be of the form x squared plus y squared is equal to 4. If you were to x to find dy dx given this equation, you would have to use implicit differentiation. Now yes, you can solve for y, and then you'll get plus a radical and then minus a radical. However, you can get just one solid answer, so one equation as your dy dx, by using a technique called implicit differentiation. So these are the steps in order to implicitly differentiate a function. So in order to find dy dx, when you're given an implicitly defined function, your first step is to differentiate both sides of the equation with respect to x, which means every term that you're going to take the derivative of, just make sure it's the derivative with respect to x. And we'll look at what that means with some examples following this. The second step is to collect all the terms that have dy dx to one side of the equation. Just like when you had to solve for x in previous equations, in this case you're going to solve for dy dx. So factor dy dx out, or group it all, first group it all to one side. Then you factor out your dy dx. So you differentiate both sides with respect to x, you collect your dy dx's to one side, then you factor out the dy dx. And then once you have a factor, dy dx times some type of parentheses or some type of factor, you then solve for dy dx. So that means you're going to divide by whatever is being multiplied with the dy dx. So these are your 4 basic steps. Differentiate everything, collect dy dx or bring dy dx to one side, factor, solve. Differentiate everything, collect, factor, solve. Now let's look at some examples. So here's our first example. Find dy dx if y plus y to the third minus x equals 7. So now remember, the first rule was to differentiate everything, both sides of the equation and all the terms, with respect to x. And that with respect to x is the little nuance here that we have to be aware of. So just to write out the notation and that you'll see how you solve this, we're going to take the derivative of y with respect to x. We're going to take the derivative of y to the third with respect to x. We're going to take the derivative of x with respect to x. And we're going to take the derivative of 7 with respect to x. What we would do with these two terms is no different than what we've done before. So you take the derivative of x, and that's going to be 1. You take the derivative of a constant, which is 7. The derivative would be 0. The new part is taking the derivative of a variable that's not x. So what ends up happening is that when you take the derivative of a term that's not x with respect to x, you're going to take the derivative of y like you normally would. But because you're not taking the derivative of that with respect to that value, then you have to make sure you place that notation in there. So meaning the derivative of y is 1. And then you took the derivative of y with respect to x, so you have to put dy dx. Plus the derivative of y to the third is 3y squared, but you took the derivative of y with respect to x, so you have to put dy dx. The derivative of x is 1, but you took the derivative of x with respect to x, which we never wrote before, right? But look at why you never had to write it. Dx over dx is 1. So we never wrote dx over dx before, but technically that's what we were doing every time. The derivative of 7 is 0. With respect to x, you took the derivative of it, and that always went away. So you see what you're left with here. You're left with 1 dy dx plus 3y squared dy dx minus 1, because that dx crosses out, equals 0. So that's the first step. Differentiate everything, both sides and all terms with respect to x. The second step is to collect all your dy dx terms to one side. So notice you have a dy dx on this side and another dy dx still on the same side. But this one is not. It doesn't have a dy dx with it. So bring that to the right side. So we're going to see this as dy over dx plus 3y squared dy over dx equals 1. I added the 1 to the other side. Third step, factor out the dy dx. So when we factor out the dy dx, if we bring it up to this side, we get dy over dx, parentheses. When you factor out of the first term, you're left with 1. When you factor out of the second term, you're left with 3y squared equals 1. Third step is to solve. So that means you're going to divide by the term that's being multiplied with the dy dx. So we're going to divide by the 1 plus 3y squared. So we get dy dx is equal to 1 all over 1 plus 3y squared. Now let's note a few things that we did here. The hardest part is going to be that idea of differentiating with respect to x. And that's just a notation that's new, that's being introduced. Realize that you want to find dy dx. So if you're not putting that dy dx in there when you take the derivative, you're not going to have it in the equation to solve. So keep that in mind as well. Now another way that people do this is they don't write dy dx. But remember, dy dx is also y prime. So to kind of break up the notation, lots of times people just write this as y times, or the derivative of y is 1 times y prime, plus 3y squared y prime. And the derivative of the x term, because it's the same variable with respect to x, you don't have to write it. The derivative of 7 is 0, we're doing it with respect to x, so you don't have to write it. So you'd end up getting here 1y prime plus 3y squared y prime minus 1 equals 0. The only difference is that instead of using dy dx, you're using y prime. So you'd factor out the y primes instead of factoring out dy dx. The only reason that sometimes is preferred is because it's a little bit less to write. So y prime is quicker. So sometimes people prefer to write y prime instead of dy dx. The next example that we'll do with using y prime instead of dy dx. So let's try this one. The derivative of x squared is 2x, because remember, we're differentiating with respect to x. The derivative of y squared is 2y, but since you're differentiating with respect to x and it's a different variable, you have to put y prime, or dy dx, you pick. Don't forget to also differentiate 4. The derivative of 4 is 0. So first step, differentiate everything with respect to x, which we did. Second step, collect all your dy dx's or your y primes to one side. This is the only one that has the y prime with it. So bring the 2x to the other side. So we're going to subtract 2x to the right side. So we get 2y y prime equals negative 2x. Factor it. Well, there's nothing really for us to factor the y prime or the dy dx from because it's only a monomial, it's one term. So we can just solve. So we're going to divide by 2y. Y prime is negative x all over y. So the only difference between this example and the previous one is that we used y prime instead of dy dx. Also note that you don't have to write dx when you take the derivative of an x term with respect to x. You only have to put that dy dx or d, whatever the variable is, over dx if it's a different variable other than x. So just make sure you read the question and make sure that you know if you're looking for dy dx, that means you're taking the derivative with respect to x. Let's look at another example.